Hello everyone. So today I will discuss this problem three sequences from the Codeforces round 670 tube 2. So we are given a sequence of n integers and we have to construct two sequences such that the corresponding elements sum up to the original sequence corresponding element, and also the one sequence is non-decreasing and one is non-increasing. I hope you know the meaning of non-increasing and decreasing, and what we have to do, we have to minimize the maximum element of the sequence, and then we have this Q queries in which we have to change the element from L to R by adding a value X, which can be positive or negative, and then again we have to calculate the value of the maximum of Bi and Ci, which should be the minimum value possible. So like I take this as case, four elements are there, 2 minus 1 7 comma 3, and then we have two queries. So let us go to the whiteboard to try to understand this thing. So it is 2 minus 1 uh, 2 minus 1 7 3. Okay, so 2 minus 1 and 7 and 3. Let us try to do some calculate some sequences. So we have to calculate two sequences, which element is like such that the corresponding sum is equal to the sum of this sequence. So if I give a number by, like, let us say 1, so then what will be this number? This will be 1, and then if I take it as 1 and keep it as such, then this minus 1 will become 1 minus 2, so this will become minus 2, and then it means like this sequence is such that like it is increasing like that, and above upper sequence is increasing like that. So then after that, if I have to say take some, if I make it minus 2 only, because if I further decrease it, then this will increase the positive value, so I will try to keep this as such. So now because if I kept it 1, then this will become like there are two cases, like if I keep it 1, then this will be like, in this case, then this will be uh, to get the sum 7, so this will be 6, but 6 is not possible. This is not possible, so that's why we will construct corresponding to this one. So this is minus 2, so this is 7, so this will become 9, and then let us try to keep this 9 as such. In the similar logic, if I keep minus 2, then this will become this will be inconsistent with the corresponding statement. So this is 9, then this is 3, so what it has to be, it has to be minus 6. So this is one of the construction of the sequence A and Bi. Our answer in this case will be 9, because the maximum value of 9 and 1 is 9. And now let us try to construct another sequence according to the rules which we have, because there are many possible sequences, but we have to choose the one which is optimal, that is the maximum of the largest value of the both the sequence is the minimum. So if I take here, say 2, let us take 2, then this will be 0, right? And then I take here also then 2, so since this is minus 1, so this will become minus 3, this will become minus 3, so minus 3 plus 2 is minus 1, so I will make it minus 3 now, again with the same logic that I have used here. So then minus 3, and then this is 7, so this has to be 10, and then I keep this as 10, and then like the element which is changing, it drives the corresponding element to become the driver. Like you keep this as, and then this element become driver, and then this element become driver of the sequence prediction, like. So this is 10, so now this is 7, right? So this will become then minus 13. So this element, this sequence will be like in this way increasing, and this way increasing the upper sequence. So the answer for this one will be the 10, and then this is 0, so the answer will be 10. So in this way, this sequence is much like optimal than this one, but we have to construct the most optimal sequences such that this value should be the maximum value should be the minimum possible. So what we can observe from here is this here 9 and here we have 1, so the sum is 10. Here we have 10, here we have 0, the sum is again 10. And if you will construct any sequence, the sum will be 10 in this corresponding to this example. So what this 10 signifies? Okay, so let us try to understand here further more. Like if I have, let us take this value, the first sequence value, the first element of the first sequence value to be 0. Actually, this problem is more or less a constructive algorithm problem. This query actually can be handled the way we handle the queries of Fenwick or a segment tree, like, but we have to calculate the base case. After calculating the base case, the problem will become very much simple. So if I take here 0, then this will become 2, and we know that the sum is 10. Even if you try to construct here, the sum will be, you will find here to be 8. So now, what is this 8 signifies? 8 signifies the increase from 0 to here, and that increase will come from the elements with the, like the larger element, the, like this increase of 0 to 8 will be given by the increase of the sequence from here to here, which is an increase value. That is, we have to take those elements, consecutive elements, which is giving a positive increase of this value. Like I want to say here that if you see that -1 and 2, this -1 is not increasing compared to 2, so this will not contribute to the difference of 8. So now if we see 7 and -1, it is contributing like 8 to the final result, and this is also not contributing. So what we have observed here, the elements which are increasing are contributing to the increase of this value to this value. And also, so this is 8, right, but our value is 10, so this 10 will come by adding to this increase the value of the first element. And then what will be the optimal sequence? The optimal sequence will be that which have the value of 10 to be equally divided between the two sequences. Like the optimal sequence should have 5 here and 5 here. Like that will be optimal, because if we give less to one, then it will be more in another one, and that will increase the answer. Actually, this is more or less much more difficult to like observe. If we do multiple examples, we will observe, we will see this logic clearly. It is much of a constructive algorithm problem. So I hope that you understand that it's a constructive algorithm problem. And now what about queries? So queries will be dealt the same way as we deal in the queries of the segment tree or Fenwick tree. Like here we have to add in the segment L to R the value X, and that X can be positive or it can be negative, right? So what we used to do when we used to add X to the sequence in Fenwick or segment tree. So what we will do, we add L, at the corresponding value of L, we add the value X, and at the element R plus 1, we add minus X. So this thing we will use in this example as well. So let us look at the code to understand this a little bit more. So here we have this input, and then the first element will be the difference. We have constructed a difference array. We have said that the first value of the difference is equal to the first value of the array, and then the corresponding differences will be the differences of the corresponding elements, like ai minus a minus 1. And then let us say now calculate the value of the answer, which we can also say as sum. So if this is first element, if I is equal to 0 or the difference is positive, that is the adjacent elements are increasing, then we will add to the value of the sum, and that in the final we will just take the floor to be the output of the problem before querying. And now after querying, when we do the query, we will add L, at the position L we will add this value of X, and at the position R we have not increased decrease this r, so that r is actually r plus 1, and add the value minus x. And again, after querying, we just again calculate this floor, and in the query what we do, we do the same logic. If our difference is positive or the element is at the first position, we will first of all subtract the sum and then increase the value of the the difference, and then if the difference is positive or the first element is it is first element, then we'll again add to the sum, and in this way our sum will get updated at each query. It's a kind of it's I know it's a kind of like you might have not understood well, or you might have understood well, because it's more or less a constructive algorithm problem. It is very difficult to explain. I hope you understand some part of the proof, if not all. So with this note, I terminate now.